Let's talk about the chemistry of titanium and some other unimportant aspects of chemistry, inorganic chemistry in the GCE A-level syllabus of Sri Lanka. There's more elaboration of titanium in industrial chemistry, however, but you see, in inorganic chemistry, there's not too much really. I'm not going to put too much effort in this video because this one is just like glimpsing over some, you know, not very popular reactions, and those that will probably not exactly come. I actually considered whether to make this episode or not even. If we were to combust titanium in oxygen under high temperature conditions like 500 degrees Celsius, we will get the white color titanium dioxide. If we do so with chlorine, we will get a transparent liquid known as titanium tetrachloride. It's an interesting compound. It's a colorless liquid like water actually. By adding excess chloride ions into titanium liquid, we will get this chloro complex, which is colorless in color. Colorless in color. It's colorless, yeah. If we were to add water into titanium chloride liquid, we will get hydrochloric acid and a precipitation of the white titanium dioxide. If we were to reduce titanium chloride using a suitable reducing agent like zinc or copper, we will get this complex titanium 3+ aqueous, which is purple in color. But we can add a base into it and get this complex TiH2O5OH2+ and a H+. By adding more H+, we will get, the equilibrium will shift to the upward direction and we will get more of the titanium 3+ solution. Apart from good old titanium, that's the best part of this video, let's just simply gloss around some other rather unimportant reactions. The first one being that of the tarnishing of sodium. Sodium reacts with water to form sodium oxide. Sodium also reacts with water in the air to form sodium hydroxide and hydrogen gas. Sodium oxide reacts with water to form sodium hydroxide. Sodium oxide reacts with carbon dioxide to form sodium carbonate. Sodium hydroxide reacts with carbon dioxide to form sodium carbonate and water, and sodium carbonate reacts with carbon dioxide and water to form sodium bicarbonate. Barium chromate and strontium chromate are both yellow. How do we differentiate them? We cannot do so with dilute acids because they both react with dilute acids, but we can do so with dilute acetic acid because barium chromate does not react with dilute acetic acid while strontium chromate does so. Carbon dioxide under high temperatures with ferrous oxide forms liquid iron and carbon dioxide. This happens in a blast furnace. Carbon with concentrated nitric acid, we discussed this reaction. We discussed these two reactions in the previous video. And sodium with carbon dioxide will form sodium carbonate and carbon. Potassium with carbon dioxide forms potassium oxalate. Magnesium with carbon dioxide reacts to form magnesium oxide and carbon. I'm actually surprised why you are still staying here, seeing how it's the titanium thing that's the most important. But good for you that you are staying. This is plumbous oxide, and this is plumbic oxide. +2 +4 oxidation state. Plumbous oxide is yellow, plumbic oxide is brown, and it forms a mixed oxide which is red, Pb3O4. Liquid lead reacts with oxygen in high temperatures to form the yellow color plumbous oxide, and oxygen will form as well. The yellow color plumbous oxide reacts with oxygen in 450 degrees Celsius unheated conditions to form plumbic oxide, which is brown in color. Then there's the yellow color plumbous oxide and the brown color plumbic oxide, which together react in 450 degrees Celsius to form the red color lead oxide. Which You can actually convert back into plumbic oxide by heating it in extra oxygen. This, my friend, is called silane. Silane with water forms this this compound, and it forms water as well. But it can also form silicon dioxide in the right conditions with, and it also forms hydrogen chloride, hydrochloric acid. This, remember we saw halogens with very high oxidation states earlier. Yeah, this is what they decompose into. They literally decompose thermally into the relevant halogen and oxygen gas. This is for except chlorine. Now we get to the last nitty-gritty parts. This is the brown ring test. To the solution containing nitrate or nitrous ion solution, we add fresh ferric sulfide and dilute hydrochloric acid accordingly. Then this reaction happens where 2H plus reacts with electron to form NO2 minus. No, it reacts with 2H plus reacts with electrons and NO2 minus to form nitrous oxide and water, and the ferrous ions are oxidized to ferric ions. The remaining ferrous ions react with NO to form FeNO2 plus, and FeNO2 plus reacts with sulfates to form FeNOSO4 bracket, which is the brown ring that we observe in the brown ring test. Nitrous solution forms the brown ring in dilute acid, while nitric solution cannot do so. Here's another neat reaction. The manganese ion with lead oxide forms the permanganate ion, and it can be reversed by adding H plus and Fe2 plus and SO2. And by adding anhydrous OH minus into the solution, we can convert permanganate into manganate. Yes, by adding anhydrous hydroxide. And these are the how oxidants and reductants are. This is what happens when they are redox balanced. I'm not going to go into that. Well, I hope you enjoyed that. I actually considered not making this episode, but I'm just limiting it to the titanium. But yeah, it'll be good. So bye. This is the most unprofessional thing I've ever done. Bye.